Hello, everyone. I'm Evan. I'll be doing the talk today um, and about the anatomy of the Python. So um, before we start, are there any questions? Of course not, right? We just started. But I'm going to take a page out of Philip Waldler's book, and I want you to keep in mind that the point of this talk is so that you can walk away having learned as much as you want to learn. So I want you to ask questions. And we also have a problem, right? Because I am too experienced in Python. I've been doing Python for 5 years, so it's difficult to know what you don't know, right? So please, if you don't understand something, even if you weren't paying attention, because I've done that myself and then I feel guilty to ask, please ask. The reason this workshop is 2 hours is not because the content is 2 hours long, but because I want to make it a more interactive experience where you can ask me questions and I can like go into the more specifics of how things work. And at the end of the day, right, there's no point in me giving this talk if you're not going to gain anything from it. So please ask questions. So are there any questions? Again, no, but I know it's difficult to ask questions online, especially now, because you probably feel like you're interrupting me and whatnot. But please don't worry. If you have a question, you can either raise your hand on Zoom and let's see, I can like lower all your hands. And if I see a hand raised, I'll like stop and talk or stop when I need to. Or you can type in the chat. And I'll have both panels open so I can see what's going on. So now someone raised the hand. Christina, do you have a question?
Are we allowed to try out the raise hand feature?
Yes, please try out the raise hand feature at any time and I will stop. That being said, if you do have a mic and you want to ask a question, I recommend using a mic. It just makes the experience a lot easier for me to be able to like interact with you a lot easier rather than reading the chat and waiting for you to type. And also it makes the recording better because the recording is not going to have the chat. Can you understand it if you haven't done 1531? Yes, depending on how much knowledge of Python you know. So I am assuming a bit of knowledge in regards to like how to write general Python, how list comprehensions work. Because the point of this talk is you know how to write Python, but you don't fully understand what you're writing, which is like a little bit important, right? But I'll still try and cater it to make it as simple to understand as possible. So feel free to ask questions either way. And lastly, if there are no questions and you all just want to be quiet for the whole time, I will pick on people to answer some. So if you don't want me to pick on you, feel free to like rename yourself and like add a star or something, and then that way I'll ignore you. I will hunt people down. Don't worry. Anyway, with all of that done, let's move on. So the Pythonidae, commonly known as pythons, are a family of non-venomous snakes found in Africa, Asia, and Australia. Among its members are some of the largest snakes in the world, like pythons. Some interesting facts about snakes is that they have forked tongues, which they flick into the air to like pick up scent particles, and then touch on the roof of their mouths, which is where the Jacobson's organ is, and that acts as their nose. Pythons also have, okay, I'm not going to actually do this. Let's actually move on to the talk. But let's see. Okay, so I think a great way of learning how something works is to do a deep dive. So let's look at how dictionaries work, right? So we know how useful dictionaries are, right? Because they can help us keep account of things or like store multiple things. So let's say we have a shopping list, and in our shopping list is a bunch of fruits. We have like apples, just one apple, a banana, another banana, maybe another apple and a cherry on top. I will make lots of spelling mistakes, don't worry. And then we also have our dictionary, which is counts. And what we're going to do is we're going to keep a count of what's in our shopping list, right? So we go for fruit in fruits. If the fruit is not in the dictionary, set the entry to of that fruit to 0. Because if it is in the dictionary, we will just increment it by 1. So counts fruit equals count fruit plus 1. And then lastly, we'll print the counts. Right? And you can see we've gone through the list and we've counted that there's 2 apples, there's 2 bananas, and there's 1 cherry, right? And maybe we want to like print it out in a more user-friendly way. And what we'll do is we will go through every key in our dictionary and print that value. That value that we get from the dictionary by accessing the dictionary with a key. And we'll do like a times and we'll put in the key, which is our fruit. So now we have a shopping list and it's got like there's 2 apples, 2 bananas, 1 cherry and whatnot. Okay, cool. So we've written like a normal dictionary that does the counts and so forth for us. But how do they actually work, right? Let's try and implement our own dictionary. And we can do that with a class, right? So we'll have class dict. And what we'll do is we'll just subclass from dict, right? No, typing is hard. Okay, cool. So now we can run our code again, and it works as normal. And why does this work? It works because subclassing or inheritance gives you all the methods from dictionary and just lets you put it back into the class you made. And now you don't have to write anything, right? You have your own dictionary that you've defined and you're done, right? Obviously, this is not what we want to do. This is cheating, but this is still useful because it means that we don't have to write all this code again in the real world, right? But again, we don't actually want to do this. What we want to do is implement the dictionary ourselves. So we stop subclassing and now we'll like see what methods do we want our dictionary to actually use, right? Well, what are some methods? Can people point them out? Get count, sure. So this one, no, sorry, this one. So we'll call this retrieval. What else?
You can get stuff. You can get something by its key.
Like, so this one here?
Oh yeah, what? You can set stuff. You can insert stuff.
Cool. So we can do insertion. And let's see. Some other stuff we can do is lookup. Like we want to see, does that item exist in the dictionary? Or rather, instead of insertion, we'll call it assignment. There's also initialization. And down here we have representation. And finally, we got iteration here. Right? Cool. All right. So let's Yeah, Simon is a great name. So let's implement this, right? We'll start with initialization, right? So we'll have a method that we want to call to initialize the dictionary to be blank or whatever, right? We'll call, so this would be our initialization. I'm going to spell so many things wrong, and I'm not going to care at some point. But our method will be called init, right? It's kind of like the init methods that you might have seen in 1531. But all it's going to do is it's going to take in this self, and we'll cover that later, and some data. And it's going to say on self, change the data to be equal to an empty list. And what we'll do is we won't go into depth on how to like implement a proper dictionary, but we'll just implement a dictionary with like a key value list, right? So it's going to be a list with key 1, value 1, and then key 2, value 2, and then like ... right? And then that's it, right? And then we have our lookup, right? So to implement our lookup, how would we do that? So like our lookup takes in a key that we want to look up. And how would we check if there's a key in our list? We could do key in list, but that's not going to work, right? Because our list contains tuples, but we want to check if the first element of the tuple is a key. Anyone?
This might be complicated, but maybe we can try to map the tuples to just a list of keys and then do in.
We could do that, yeah. Or Joanna says we could try return, oh, I can't type, return any key is equal to element 0 for element in self.data. That would work, yeah. Cool, okay. So then let's try some other stuff. If we want to retrieve an item, maybe we'll retrieve, or I can't spell. Maybe we'll do something like get item. We want to have, we have self and the key, and then how do we get an item this time? We could do what we did before with like an any and then so forth, but we can just make it really simple, right? Filter will return you. I think the concept of filter, though, the idea is you filter out items from a list and get back multiple other items. But like we don't have to be super complex, right? We can just write something simple for now and fix it up later. So we can just do for key value in self.data. If the key is equal to the key, like if the key that we're iterating over is equal to the key that we're looking for, return its value, right? And if it doesn't exist, then Python says that it should return a key error, right? So if we have our dictionary like this, and we try to look for a key, and it doesn't exist, it's going to say key error key, right? So what we'll just do instead is raise key error on the key. we want to look for. Does that make sense? Okay, let's go on. So for assignment, we'll do def set item with a self, the key, and the value. And then we just do if it's not in the dictionary, self.data.append, right? So we'll look at our, like if it doesn't exist, we'll just add it to the end of our list, right? And otherwise, if it is in our list, we want to look for the item and then change that, what is inside that item, right? And the way we can do that is with a for loop, right? And so say we like look for the key and value in self.data, and we say if key is equal to the key, self dot, like, okay, how are we going to change the value now, right? We don't have a reference to what we had before. We only have a reference to the key and the value. And if we do v is now equal to the value, that's not actually going to change what's stored inside the dictionary, right? It's only going to change the value of this variable here, right? Like what it's assigned to. And what do I mean by this? So here's an example, right? In C, we have boxes, right? And when we do an assignment like this, I should probably make it bigger so it's more readable. When we have an assignment like this, we put one in a box called A, right? And then if we change what A is, we take out the 1 and we put in a 2 instead. Now, if we do something like this, where we do B equals A, then we make a new box and we copy the constants over, right? But what we have in Python is like these name tags, right? So when we say A equals 1, we get the name tag A and like wrap it around 1. And then when we say A equals 2, we take that name tag off of 1 and put it on 2 instead, right? So now the A is attached to the 2. But if we do something like B equals A, all we're doing is we're changing where that name tag is, right? And instead of having 2 separate boxes, we have 2 name tags and we've wrapped them around both the same object. And so here, what we're doing is we have a list of values and keys. And what we've said is that this, let me make this bigger too. What we're saying is that this V is pointing to this value, right? But if we change this value, if we change what V points to, it's not going to change the value underneath. It's only going to change what V is pointing to, right? So we can't edit what the variables are in the same way that we would be able to do in other languages. So what we would have to do is actually access the list itself. And we can like do a for in range or whatever, right? But what we should do instead is use enumerate. And enumerate will return a list of tuples where the first element is the index of that item and the second element is that item, right? And what we do here is we say, give me the first item of the list and then unpack the key and the value of, sorry, give me the first index and then unpack the item into the key and the value. It would be exactly the same as if we did something like this. I is equal to E0, key is equal to E1, 0, and V is equal to E1, 1, right? But doing like this is just a lot more simpler and concise and more Pythonic. And okay, and now that we have an index to the list, what we can do is say, okay, go to where that item is stored at that index, and then reset that item to be the key and the value. Is it text squished? Is it not readable? Can you see, Michael?
I think it's readable.
Should I make it bigger?
Yeah, it does no harm. You can probably make it bigger.
Okay, cool. And we'll just put this. Okay.
Yeah,
I think
that's good.
Kai also had a question. Why does contains work? Any will return true if any element inside this self.data matches this statement here. And this statement says, does this key element 0 match this key, right? So we could also simplify this. Like I said, we could do key and the value. And then here we could set this to key. And it's basically just going through the list and returning true the first time it finds a true value. Does that make sense? Is it K and V in for K, V creating a copy of the value but not pointing to the original value in the list? It's not creating a copy. It's creating a name tag that points to that value, right? So, so like here, right? This key would be the K, and this would be the V, right? And then every time you loop, you like reassign that name tag to the next ones up, like this. But because these are name tags and you're not pointing to like where they're stored, you can like move them around. But if you change what the name tags point, like if you do K equals whatever, you're not changing the values inside themselves, but you're changing what they're pointing to. Does that make sense? Okay, awesome. Cool. So are there any other questions? It's kind of like a pointer in C, but a bit more complex because it knows like how many things are pointing to it and so forth. I will cover a bit more of it later when we get to it, and then it will make a bit more sense. But let's see. So, okay, so we found the item. And now that we found the item, we just want to break because we found the item, we've changed it, and we're done. But now let's look at representation. And we'll call it string, text in itself, and it will return. We want to like copy what the dictionary looks like when we print it, right? So let's say we have this, and then we print it out. We have something like this. So, okay, it has a starting brace and an ending brace, and in the middle, it's got like this key and a value. So it would be something like key value, right? And then we want to do this for all the keys in the dictionary. So we'll join them with commas, and we'll just put this on new lines to make it a bit clearer. And we'll just do that for key value in self.data, right? And now we have a representation of that object, right? And what else? Oh, we also want to do iteration, right? So we'll just define an iter method that returns a list. And when we iterate over a dictionary in Python, we're just iterating over the keys, right? So if we did something like for k in D, print k, we just have the keys, right? So what we'll do here is we'll just return k for the key value in self.data. Right. And now we have all the methods we wanted. Are there any questions? Okay. And if you do have questions, just feel free to ping anytime. So let's try now and use our new dictionary on what we had before. So now instead of doing the inbuilt dictionary, we'll use our own dictionary. And it's not going to work, right? Because all these are special methods and we needed to use our methods. So we can update that. We can just say counts.contains fruit. Typing is hard. And here we can do counts.setItem fruit, and the value we pass in is 0. And then for retrieval, we'll do the same thing here. SetItem fruit. And then here we do the get item. And lastly here, we get the string, right? And we can run that. Isn't that actually data? What happened there? Right. And because we're doing it by ourselves, we also need to initialize our dictionary, right? So we would do counts.init. And now that sets data to be equal to the empty list. And now we get a key error. Why do we get a key error? If you know the answer, please let me know. Let's see if this code is correct. I will cover that, why .string doesn't get confused with the inbuilt string right after I fix this bug. But let's see. What was the error? Set item fruit counts, get item fruit +1. I raised the key error because, I always get this wrong. We didn't update this one. In this one, where is it? For contains, don't you need a value? Isn't the value fruit? I might be wrong.
If not contain?
Oh, yes, yes. Okay, thank you so much. There we go. Wonderful. Ah, cool, cool. Okay, so now our dictionary works, right? But as Jenny said, like, why doesn't string get confused with Python's string? And that's because Python's, like, when Python calls string, when you call string on an object in Python, so if we did here, string D, right? It will call this special method that's part of the object, and that method is called string, right? And this is what we're going to exploit now, right? Because if you look at this code, it's quite ugly, right? It looks like Java code. It's just a bunch of methods everywhere, and it's a lot more difficult to write, and it's just not as simple as it was before, right? So let's go and re-implement all of these functions by using the Python special methods instead. It's actually going to be quite easy, right? Because we've already defined what they're meant to be. So our init, we just put two underscores on each side. We do the same for contains. We'll do, they're also called dunder methods because they're double underscores. Same for set item and string and iter. Cool. And now if we remove this and go back to this version, which we can just run it, and change this to use our own dictionary, it's almost going to work because we haven't updated this. So here we'll just do contains. And we'll run this again, and now it works, right? Awesome. So now what we've done is we've re-implemented our code using the standard Python syntax, but we've made our syntax actually access the methods that we wrote ourselves, right? And then when we call something like string on our dictionary, like print, it's going to print us our string. It's going to use our string function, right? And we know it's going to do that because we can add whatever we want here. Right? That's cool. Now, this will work either way, right? Even if we remove string, it's still going to do the same thing. And the reason it does that is because print by default will call the string method on the object you're giving it before it prints it, which is just another helpful thing. And if it doesn't exist, it will call the repro function instead. And what do I mean by that? Well, you might have noticed that our string here is actually quite different from what we're printing up here. Well, it's different because we have this thing, right? But if we run it again, oh, I haven't removed it. We run it again, and it will be fine after I run this code, right? But it doesn't have these quotes around it. And that's because those quotes are generated by this function called repr, right? And what repr does is it returns you the representation of that object, right? So we can give it a number, and it will return you a string, which is that number, right? Or if you return a dictionary, it will give you a string of that dictionary. In our case, like here, we could do repa D, and now it gives us a string of this dictionary, right? And why does it give you a string in this format? Well, Python, like the repa function in Python, what its aim is to give you back a string that you could copy and paste into your Python code and use like a normal variable, right? Or like a normal line of code. So I can take this, right? Copy it and say D is equal to this, right? And now I can say, okay, let's call this dictionary 1. And this is dictionary 2. And if we do D1 equals D2, we'll get back true because they're the same, right? So let's try and fix our code up to do that. First, we'll call repa on our key and value. And now when we print it out, we'll get the strings around it, right? But you might notice that if we call, you might notice that our string method on our dictionary doesn't return a representation of how you would copy and paste it and run it within our dictionary. We have pretty syntax to make it so that if we print our dictionary, it will look like, that's not meant to, wait, sorry. If we get the string of that dictionary, it will look like a normal dictionary. But as you saw before, if you're trying to get the representation of it, it's actually just going to give us the memory address of that object. And that's just kind of the default of what Python will do if you can't represent that object. But we can represent that object. But first, for us to be able to do that, we have to be able to initialize it like we're initializing this dictionary. We can't do it using this method. So what we'll do instead is we can say, you can initialize a dictionary using no variable, or you could do it by passing in an iterable, right? Something that we can iterate over. And we'll say it's none by default. And we'll do that because if it's if the iterable is none, then we'll just say we want the data to be an empty list. But if it's not none, it's hard to read now. Then we want to initialize our key and values storage with the keys and values of our iterable, right? So we're going to do self.data is equal to the key and the value for the key and the value in iterable, right? And now we can do something like this. We can go dict key value, and then if we get the string of that, oh no, what happened? Init takes one argument, but two are given. Two are given? Self-iterable. Well, two given. Oh, I haven't saved this code yet. The wonders of Jupyter Notebooks. Cool. So now we've created our dictionary by initializing it, right? And now we can take the same thing that we did, but just have it in repa. So we'll do repa, and a lot of Python functions are actually just defined like this, by just having their names and underscores, which is nice. And we'll go return me the dictionary with the items inside, and we can just do self.data. And now when we do the repro of the dict, we get an empty dict, right? Or if we initialize it with a key in value, so we can just remove this, it will give us back exactly the code we wrote, right? Which is great. So by default, if it wasn't obvious, my Jupyter Notebook will print out the representation of the object when you just leave it like this. But if you print, it will give you the string of the object. I hope that's making sense so far. So are there any questions? Okay, cool. All right, let's clean up our code a little bit before we move on. What is this? Oh, are you drawing? I'm gonna not let you do that because then it will be. There we go. Okay, it'll be very confusing. Okay, cool. So, let's look at our code a bit and see where we can clean things up. One of the places we can clean up is like these pluses. It's a bit of a mess. So what we can do instead is just like join them all with an empty string, and we'll put them all in a tuple, right? So we have this and this method. And then finally, so now we know it starts with this, ends with this, and has this in the middle. And I think that's fine. Let me just double check. Okay, cool. Awesome. All right, so the next thing we're going to cover is the next problem with our code. So you'll see before, we actually had this iteration thing, right? And we forgot to test it. So if we test it, you'll see it doesn't work anymore. And that's because before we could have done this, and it would give us a list. Actually, let's try this. Maybe this will work. Oh, cool. So this works, right? Because all we're doing is we're iterating over the list that it's returned by iter. But by default, we implemented the iter function so that we could actually go through the list like we would normally in Python. But it's not working because it's expecting, like the iter method expects that the type you're going to return is an iterator. And in this case, we're returning a list. So how are we going to fix that? Well, we can just return the iterator of that list, right? And now when we run this, come on. Oh, we have to reinitialize what counts is. It works, which is great. But that doesn't really answer our question for what an iterator is and how it works, right? So let's try and implement one. Like we've implemented a dictionary, let's now implement an iterator. Oh, I forgot an important part. You didn't ask enough questions. Okay, before we jump into how an iterator works, let's look at how these functions work, right? Because it's still not quite clear why this is actually happening and why we have self. So we have our dictionary, right? And we're doing something like this. And then we can get the value out. Cool. But we already said that like the way this is working is what Python is actually doing is calling set item with the key as the first argument and the value as the second, right? And here, what we're actually doing is get item with the key as the first value, right? And you can see how from before that all we're doing is just accessing the methods of the dictionary and calling these functions. They're just normal functions, but they're just named differently. And then passing in these arguments, right? But if we look at this function up here, you'll see it's got this self, right? Like if it's just a normal function, why do we need to put in self? And the reason we put in self is because it needs to know what object you're actually looking at. Can we put in any word? It's a good question. Let's find out. So let's not put self. Let's put like S or something. And then here we can, yeah. And the reason why is because when you're writing code like this or code like this, Python will convert it into the proper code that it's actually running, right? Because all of this is just syntactic sugar. It's just sugar that's sprinkled on top to make writing code easier for you. No, we're not going to use this to make it look like Java, because unlike Java, you need to put self. But let's go back, right? What Python actually does here is it gets the dictionary itself, like the class itself, and gets the method from that class and puts in our instance for us. So the reason we have self is because when Python is running the code, what it does is it goes to our instance of the class, it goes to our class code, it looks for the function that we wrote, and then passes in the instance as self, right? And that's why we need to have self, because if you want to work on an instance, you need to have your instance to work on, right? Because the thing that's storing the data is self, is the instance itself, right? Stop autosaving. Okay. Why don't we need to do this in Java? I don't know. Because Java does everything implicitly. It will implicitly convert strings to ints for you, or no, ints to strings for you, and it will implicitly include everything inside your class in the methods, which is why you don't need to do this dot data or this dot like self dot function or etc. Right? I think so. Anyway, Java is not my favorite language. I don't use it that much, as you can tell. My opinion, this is way better because it's more explicit. But like we haven't finished here, right? Does that answer your question, Kai? Yeah, cool. So we do the same thing here. And you might be thinking, okay, how does it know that dict is the class of this method? It doesn't. What it does is it gets the type of that instance, right? And if we look at the type of D, we see it's the class dict, right? And again, we haven't really finished because you notice before we have this init method, and that's like being executed somehow, right? And what Python does is it executes it inside the new method, I believe. So really, when you do this, what you're doing is this. Something like this, right? And then inside this new method, you would be running this. Right? And then this is why you have the init method. And like the new method gets done for you, but you need the init method to be able to instantiate your class. So unlike Java, where you have like a proper constructor, Python's constructors are implicit, like they're already there, they're done for you. But what you have instead is an initializer, where the constructor is already done for you, but you want to initialize all the variables inside the constructor. And again, like this isn't 100% how Python does it, but this is a more simplified way. Like it goes a bit more detail, and it's not really like, it's for another time. We can skip that. Is there a new keyword in Python? No, not a keyword, but a function. So you can do new like this, but it's done for you when you do something like dict. What do you mean? Yeah, like the keyword is kind of equivalent to new, but it's not really a keyword. It's more of a function on this object. An object is just like the highest-ish object that you have, right? Does that make sense? Yeah, Python is object-oriented. I don't know why you thought otherwise. But it's less object-oriented than Java, and we'll cover why later. Or will we? Imperative just means that you're like running through the code step by step, as opposed to like functional. I believe so anyway. A lot of languages are just a mixture of everything, because, you know, people like everything. Yeah, let's leave it at that so we can move on. So the next thing we want to look at is iterating, right? What is iter, and why does it work for this? So an iterator is something that you can iterate over, right? And every time you do for item in object, what the for loop is actually doing is getting the iterator of that object, right? Something like this. And it gets this iterator by calling the iter function, and it returns us another iterator or whatnot, right? So let's look at, like, I know it's a bit complicated. So let's look at what like an iterator of a string looks like, right? We have a string ABC, and we've saved it to an iterator. So we can look at this iterator, and you can see it's like an object in memory, and I'll explain why later. But when we want to get, like, when we do the for loop, unlike a string where you can, you know, index it, you can't do that with an iterator, right? Because it doesn't work like C, right? the idea behind an iterator is that you can only access one element at a time. And we can do that with the next method. So we get the next item of I, and that is A, right? And we can keep doing this. If we want to get the next element after that, it's B, and then C. And then what's going to happen now if we run next again is we'll get a stop iteration, right? And the reason we get a stop iteration instead of some value like none or whatever is because we could just have a list that's full of nones, right? And how would you be able to differentiate when you've reached the end or not, right? And yeah, exactly. Stop iteration is an exception, that like an error that's raised up so that you can catch it and do something about it, right? And we always have to return stop iteration once we get to the end. Otherwise, the iterator is deemed to be improper, right? So now that we know like how Python special methods work, how iterators work, and whatnot, we can actually implement our own iterator, right? So we'll implement range, right? We'll make it a bit simplified though, and we'll do we pass in itself and a stop. And a stop is just where do we want to stop, right? And we'll do, we start at 0, and then we'll stop at stop. And we also need to define what happens when we call next, right? So we'll do next. That's not how you spell self. It doesn't matter. So what happens when we call next, right? We want to get the next item and return it unless we're at the end, right? So we can do num equals self.num. And we can do like, we can just return num, right? And what do we think will happen here, right? If we do r equals range 10, we can print out r, right? But if we try and iterate over r, we'll get something like this. Oh no, it says it's not iterable. And it knows that it's not iterable because we haven't defined an iter method. So let's do that. And what's this method going to do? Well, an iterator needs to return its like another iterator when you ask for its iterator. And that's how you know that an iterator is an iterator. That sounds very confusing, I know. But essentially, all we need to do here is just return itself, right? Because an iterator is defined by a class or some object that has the methods next and the method iter, right? And now if we do this, we need to redefine it. Missing, oh, I don't need this. It's going to print a bunch of zeros, right? And it does that because we haven't actually told it when to stop, right? So let's do that. If num is bigger than or equal to self.stop, raise stop iteration, which is essentially what was happening before, right? And our for loop will do that for us. Like we'll catch the stop iteration for us sometimes. Ah, right. Yeah, the issue here is that we haven't actually incremented what our number is. So now we go from 0 to 9, and then we get to 10, and 10 is bigger than or equal to the current, like the stop value. So we raise the stop iteration, and our for loop stops. Does that make sense of how like an iterator works now? Are there any questions? Sounds OP. Yes, it's very nice. Okay, cool. So what we'll do now is we'll look at generators, because this is not how we actually implement iterators. When we really want an iterator, what we want to do is use a generator instead. And the way we can write a generator is exactly the same as a list comprehension, except we use a, like for example, I for I in range 3. It's exactly the same how we use a list comprehension, except instead of putting square brackets, we put round brackets instead. And you might be thinking, oh, why doesn't that just make a tuple instead? With tuples, you've got to be more explicit and actually put, like, construct them like this. So if we look at G, it's a tuple. But if we want a generator, we would do this instead, right? And now we can use it in the same way like we did before. Print I, right? And we just go from 0 to 3 and we print all the numbers, right? But the difference with generators, unlike list comprehensions, is that with generators, you can exhaust them, right? So if we make another one here, that's a list comprehension. And we have a for loop. We print all the elements in L. We can run this code and run this generator, and we can run this list. But if we run the generator again, we'll have run out of all the elements, right? We can, because all the for loop is doing here is just getting the next element, right? And the next element doesn't exist. It's already reached the end. But with lists, we can just keep calling it as much as we want, right? Because lists are defined and expanded and sit in memory, right? Whereas generators aren't. With generators, you only store the value that you're expecting to get next, or like you only store the code that you need to get the next item and like where you're currently at. Whereas lists, you store the entire list itself, right? Which is why when you print out a generator as opposed to a list, you get a generator object instead of a list, right? Because our generator here, like we had it before, could just never stop, right? And with a generator, we don't care about that. We can call next as many times as we want, apart from that time. Oh, we need to use R instead. We can call Y. Okay, there's our range object. We can call our generator as many times as we want, and it will just keep giving us the next one, right? Or we can redefine this to include a stop, and instead we'll say we'll stop at like billion or whatever, right? Maybe not that large because then my computer won't be happy. What's a million? Something like this, right? So again, when we print out R, it's fine. But what if we try and make a list of 1,000,000 elements? It's going to print out a fair few of them, but what if we just add more, right? We're going to run out of memory. And now we aren't able to loop through all the numbers from 1 to 1,000,000,000 or whatnot, which is why generators are important, because we don't need to store everything in memory. And even if we could store everything in memory, look how long it's taking for it to compute. Stop, please. I lagged a bit there, but you get the idea, right? Like if I was to find you how big this list was, it would probably be megabytes in size. Okay. Let's see. There are some other ways to make generators, but I think so we can cover some more stuff, we'll leave that at that. Let's restart this so I'm not lagging as much. All right. So, cool. So, the other important thing to talk about generators is that you don't actually need the round brackets around it. So you could do something like this. Join all the numbers for I in range 3, right? It's because I removed everything, but let's get rid of that and this. Sorry. And the reason we need a list comprehension here is because we need to convert them to strings, right? So we can put the brackets here if we want. What's wrong now? Expanded end of file. I think I missed the bracket. Cool. We can put the brackets here if we want, but it's not actually going to make a difference because all this generator is doing is just returning an iterable, right? And we can put this basically wherever we want. The only reason we need to put brackets here is because the Python syntax won't be happy with it because it doesn't know like where it's starting and where it's ending. Cool. Does that make sense of how an iterator works? Does anyone have any questions about that? Okay. So now that we know how an iterator works, why don't we try and implement our own for loop, right? And we can do that by making a function, right? And what that function, like our for loop will do something like this, firstly, right? For item in iterable function item, right? And this function could be print or int or whatnot, but we'll just make it function. And what we'll do is we'll make our own loop as a function that specifies the iterable and the function to take in, right? This might be a bit confusing, right? Why is it that we can do this, right? How do we pass in a function that we can just call like this? And the reason is because functions are just objects, right? Everything in Python is an object, as you've seen it here, right? Like a generator is an object, an iterator is an object, a dictionary is an object, and whatnot, right? Functions are also objects. And we can pass them like this. And essentially, if we want to write a for loop that looks something like this, for item in range 3, print item, you can think of them exactly like you have a variable, right? We can just instead, let's run this so you know what's happening. We can just instead put in the iterable as range 3, right? And the function as print. And we only ever actually run the print function when we put the round brackets around it, right? So all we're doing here is we're just like getting these variables, putting them here, right? Well, not here, sorry, but here. And we're just running the code as normal. Cool. So let's try and make our own for loop, right? But without using for. So we already know that a for loop is basically a while loop, but everything is in a different place. So we can just do while true, or rather, like, actually let's implement a for loop first. A while loop is a for loop first. So if we did something like for item in range 3, what, like in the C style, we would have start equals 0, while start is less than stop. We'll do stop equals 3. Print I, right? And we'll do I equals start, print I, and then I plus equals 1, right? So now we've essentially mimicked exactly how, almost, well, I is smaller than stop. Well, I is smaller than stop, sorry. We've essentially mimicked exactly how a for loop would work, right? So let's try and do this with an item, right? We don't have the ability to go next, like I plus 1, because we don't have an index. But instead, we have the next method, right? And how would we do stop? Well, we have the stop iteration. So let's try it. Def loop iterable function. And what we'll do is we'll say while true, and we want to get the first element. No, what's a less confusing way? We'll do while true, and we'll just like implement our ability to stop, right? And we can do that with catching the exception, right? So at some point here, we want to, okay, hold on, no. All right. So let's do like print I and then I plus equals 1. This isn't going to work, right? But what we want to do is get the next item, right? So we can say item is equal to next of the iterable. But this isn't going to work either, because we should be saving, like, because just because we get the next of the iterable doesn't mean it has a next method. We need to get the iterator of the iterable. So we'll store that up here. Iterator equals iterable, right? And so here we want to get the next item of the iterator, right? And so now we'll just keep going next. And if we run this function, let's just copy this one from above. I had a reference before assignment. Yes, sorry. Okay, now we get our stop iteration, right? And we get our stop iteration because we've got an iterator, we get the next item, which is 0, we print it, we go to the next loop, we get the next item, which is 1, and so forth, right? Until we get to the stop iteration, which just gets raised up to the main program. So what we want to do here is try and perform the next action, which is try and get the next item. But if this next item raises a stop iteration, then just break the loop, right? And otherwise, print the item. Cool. And now we have a for loop that works. We can just change this function to function. Right? And now we have a for loop that we've constructed ourselves using Python's Iterator protocol, right? So again, all we're doing is we have the iterable, we get its iterator, we try and get the next element. If it doesn't raise a stop iteration, run the function on that item. But if it does, just break and then stop running this code, right? And this is essentially how for loops work in Python, right? And a big problem that people have is that they always, a big problem that people have in Python is that they always use a range over a list instead of the list itself, right? Because if you're doing a range over a list, all you're doing is you're just getting numbers, right? But next lets you get the items themselves, right? Because this could be a string, right? Or anything that you can iterate over, like a dictionary. Right? So I hope that kind of makes sense as to like how for loops and iterators work in Python. Are there any questions about that? What does the else do? Yes, so we actually don't need the else. We can just do this instead. Else is just a way of us compartmentalizing what the how the try except works. So try except has else and it also has finally. And xrange is long gone. Xrange, for reference, is the iterator range in Python 2. Because in Python 2, whenever you called range, you would get a list back instead of an iterator. But because that's slow, they shifted it over. But yeah, the reason you have try except else finally is when you want to like, yeah, do certain things differently. So why you have finally is because you might have something like open file, like f equals file. And then when you open the file, maybe you have some issue or whatnot, right? Maybe after you've opened it, the file doesn't exist, or no, the file exists, but there's something wrong with it, or something like that, right? Or maybe a better example is like you try and you open the file for writing, but the file can't be opened for writing, and so it's still open for reading or whatnot, right? Finally is for you to be able to do something like f.close to close the file. And the else is where you would do something like f.write to write to the file. And this is essentially what the with statement in Python does, right? It will try opening the file. It will try opening the file, and if it can't open the file, it will like do a bunch of other stuff. I was going to cover it, but I didn't think it was super important. Why don't we use a generator? Hold on. I just lost my train of thought. Okay, so Kai's question is, why don't we just put everything inside the try? Because for two reasons. One, if we put all of this inside the try and we just had try except, then we have two issues. One is inside our try, theoretically, in this case, probably not, but theoretically, any of these lines of code could raise a stop iteration. And so if you stop at one of these points, you're probably going to have an error in your code because you're expecting the error to come from this particular function, but you're catching behavior from a different line. Does that make sense? That's the first reason. The second reason is that as soon as you catch something, you're going to stop executing whatever it is, right? And if you were meant to close the file, you're not going to be able to close the file after you do the try, after you catch the try, right? Because you've already stopped, which is why this is where the finally comes into place, because then you can try something, catch it if it gives an error, otherwise do the else clause, but finally, right at the end, close the file, because either way, you're going to be done with it. Yeah, it can be in the try, but again, the issue is that your other, you should generally only have like one line of code in the try, because you're expecting that particular line of code to give you the error. You don't need else, but again, if you're going to have a finally, you can't have the else somewhere else, right? Because you won't be able to do those operations and then close the file. Does that make sense? Cool. Now the other question was, why don't we use a generator to implement the loop rather than an iterator? You mean this one? Sorry, I deleted a bunch of it. Let me make a copy. Yeah. So why don't we use a generator instead? We should. Yeah, we definitely should. But the reason I'm doing it like this is so that you can understand how a for loop works, right? We could just return, we could just do function item for item in iterator or iterable, right? Because in this case, we don't need to get the iterator because the for loop will do it for us. But again, having this generator just means that like our for loop is back, right? Which is why we need to do it like this. Does that make sense? Cool, cool. Okay. All right. If we have multiple lines, it throws an error, and should we encapsulate all of them within the try except or separate them into separate tries? So one of the nice things about Python is that you can separate them into separate tries. So you can do something like this. So if you do try except, it's generally bad practice because what you're saying is, I want every single exception you could ever give me. And that can include stuff like a keyboard exception where you do Control C, you can catch that in Python. So if I do something like input, try running this code, input, except, and then we can put like print gotcha or something like that, right? Here it's expecting us to do something, but we can just Control C somehow. How do I Control C in this? No, don't add as a bookmark. I think I might stop. Does that make sense? So like we stopped we put a keyboard exception up to stop it from running. Like this basically interrupts it. Like a Control C interrupts your code, right? And we can do it like this, right? Instead, we can say catch keyboard exception. I think. Let's find out. And we stop. Keyboard interrupts. There you go. You can see it's an error, right? But another thing that you could do is you could have like the int of the input, right? So let's put this as a interrupt. We run this line of code. So now if we stop, we'll get gotcha. But if we run it again and we put in a string instead of a int, we have a value error, right? So what you can do here is say, if it's a keyboard interrupt, print gotcha. If it's a value error, print not a number, right? So now we can run this again, and now if we put a number, it's 10. If we put a string, it prints not a number, and if we try and stop, it'll get us, right? I don't think that answers your question though. I think the question you were asking is, if you have multiple lines that throw an error, should we break them into separate tries? Yes, you should break them into separate tries, because again, you don't know where that error is going to come from, right? So as an example, you could have I equals input and then int I. And both of these lines of code can return different exceptions, right? We're catching both of them like that or like that. Wait a minute. That's not right. Not a number. Here we go. Right? We're catching both of them. But for all you know, int itself could return a value error, sorry, a keyboard interrupt as well. It won't, but you know, hypothetically it could. So yes, you should have them as separate statements. So you would do something like this. Something like that, right? So now in the first try except, you wait for a keyboard interrupt, which it will get, and it will try to run this code, but it's not a number because it just returned a string or none or whatever, right? And then it returns not a number. Does that make sense? Okay, cool. All right, so another big question is, why is it that we can define item in this like level of indentation and use it in a separate level of indentation, right? And the reason that is because the reason for that is because Python scoping, unlike C, where in C you might have something like this. C, you have like int I equals 0 if we have like another variable which is j equals 0 as well. If I equals j, well, I can't even write C anymore. Then do I plus plus. But if it's not equal to j, then do yes. If it's not equal to j, then do I minus minus or something like that, right? If I can write code. Cool. And in C, we can't do something like initialize our variables inside here. But in Python, we're free to do that as much as we want, right? And the reason for that is because Python scope, unlike C scope, where it's limited to every different like brace and everything above it can view it, in Python, you can view everything above, but your scope is now a scope in Python is defined by a function, a module, or a class, right? So, which is why you can access those things. And in particular, you can view those objects as you wish. So let me give you an example. And here's like an example from, here's an example from 1531. The last week you had to write some code that would change a list outside of the function, right? So you would have like append I, right? And you can actually run this code, right? If we did add, and then let's write another function that does a check. And all this function is going to do is print I and L. So let's check what it is, add, and then check again, right? You can see we can still access and view the variables from our scope above, but and we can print them out, but we can't edit them, right? We can edit them in the sense that we've appended an L to a list, but we're not actually changing what L is pointing to. What we're doing is we're getting the reference to L and changing the underlying data structure, right? What kind of like what we covered before. So if you have another method called inc, and we did global, sorry, we just did I plus equals 1. And then here we can inc, increment, and we check again. It's going to give us an error because we're expecting, we're trying to change what the value of I is, but we don't have access to it because we haven't defined it. It's been defined in the scope above us, so we can view it, but we haven't defined it in the scope within us to be able to change what it's referencing. And this is where global is useful, right? Because what global does is it says, I'm going to redefine I within our scope, but it's going to be the same I as the scope above it, right? So now when we run this, and we'll add another method just so we can see. What do? We check, we add, we check what the contents are. I and L is zeros. Then we add 1. So we've added 1 to the list. Then we increment I, and then we can add another I here, right? So I hope that kind of makes sense as to how lists work how scoping works in Python. Essentially, if you have something like this, like if you have something like a list that's a mutable object in your top level code, you can change whatever's in the object, but you can't reassign what L is equal to. Like here, we can't say L is equal to an empty list, right? Because we haven't defined L. Cool. I think someone had a question earlier about that, and I hope that answers it. Okay. Are there any other questions?
So scoping is not defined by the blocks, like the indentation, it's defined by functions and like module and the other thing you said, right?
Classes, yeah.
Does that mean you can define a variable inside like a for loop and then access it outside?
Yeah. So, and you might have already noticed this, right? If we do for I in range 3, print I, we get I is 1, 2, 3. And if we do print I again, it's just going to be 2, right? Because the for loop has assigned I to a has got the name tag I and put it onto those numbers as it goes through, right? So if you had an I from before, 5, for example, and we print I just for clarity, our for loop will have overridden our for loop will have overridden that variable. Well, not overridden, but like changed where the name tag is pointing to. Does that make sense? Okay, cool. And Ronnie says, so by view, you can grab the reference to L, but you can't like change the name tag. Yes, well, you can change the name tag by doing global L. And then you would do like L is now actually a dictionary, and then you can do I is a string or whatnot, right? And now it's changed it for everyone else. Yeah, essentially because L is essentially a pointer that points to an area, like it's a pointer that points to an object that you can change the insides of, you can change what's inside it. Does that make sense? Cool. Okay. Yes. What Rani said was correct. Okay. So, now here's the other question you might have, right? Which is, if in C, variables are initialized and destroyed whenever, wait, I got another question. Missing the fact that if you use global, you can change the name tag. Yes, exactly. So in C or C-like languages, they have a thing called RAII, and I don't remember what it stands for, but essentially the idea is within every block, you create and destroy, like every block only has the contents of that block, and at the end of that block, you like destroy those contents. So essentially, it's kind of like that with statement, right? Which is like with open file. All right, Michael says it's RAII's resource acquisition is initialization. Yes, that sounds about right. So with open file as F, like print F or whatever, right? With is essentially doing with is essentially doing what RAII is doing for us, right? It's opening the file, and then once it gets to outside the scope of width, it will close that file for us. Unlike C though, we don't do this normally with our variables. And this is kind of bad because then like when C just destroys everything at the end of a scope, when do we destroy stuff? And we destroy stuff by a thing called garbage collection. And essentially what we do is we have a bunch of variables and we initialize them. And every time we initialize a new variable and something is using it, that variable has a reference count. And essentially it's saying someone is using this variable, right? Or someone is using this object, right? So in the case of our list, we have I is this list. Let's go L1. L1 is this list. And if we do L2 is equal to L1, we just have another name tag, right? So now this list has two references to it. And it's not going to be deleted unless we tell it to be deleted or it loses both of its references. And we can do that by using the del method, right? This is really hard to show, but essentially you can like delete the references using del. It's not that important. But then what ends up happening is that once this object no longer has a reference, a garbage truck will come past every so often and see, is the reference empty? If it is, I'm going to pick it up and just delete it, right? And then that's how Python does its memory management. And I think also Java does that too. I'm not sure, but this is like the kind of two different ways that you can write a programming language. Either you have a garbage collector that comes along and collects all the garbage, or you delete the variables yourself. Well, not yourself, but programming language deletes the variables for you in the scope. Del, I think, deletes the reference, not the variable itself, because we can test that, right? If we do L2, we still have access to it, right? But if we try and do, here, we can show it like this, actually. If we try and print L1, L1 doesn't, the name tag doesn't exist anymore, right? So it's essentially how that works. But now you might be wondering, like, okay, how do we copy things then, right? If every time we do an assignment like this, we just copy the name tag, how do we copy the item, right? And essentially the way we copy the item is by doing, we like reconstruct the item. Let's try and, no, sorry, Python is not allowed to do something like int_l. Good question. No, I don't think so. I'm 90% certain that I don't think you can do that. I mean, you can do anything in Python, but I don't think you can do that because it needs a value. I mean, C just assigns it like an arbitrary value as well, but you just don't explicitly assign it a value. All right, so like so here's the normal problem, right? We might have something like this, and we do L1.append 0, and then we print L1 and L2, right? Because both of those name tags are pointing to the same list, you're changing the same reference, you're changing the item underneath both of those references, right? So what we want to do is reconstruct the list. And a lot of things will already do this for you, right? So we can, like, list has a copy function that will give you a copy. And it all, or you can just like reconstruct the list. And that works too, and it's generally preferred to do that instead. One thing to keep in mind though is that if we have a list of lists, right? If we have a list of lists and we make a copy like so, L1.copy, then I need to construct a list within list 2. Yeah, I think so. So maybe like, maybe something like this, right? And we copy it. We can do this. But if we like get the first element and append to that, you see how it's appended to both? Because again, we have a reference to the same object, right? And copy won't fix that for us. What we need is a deep copy. I'm not sure if this exists. No, but there's a module that will go and do a deep copy for you. But this is what we mean by like a shallow copy. I think though, let's try this. Yeah, this still has the same issue. But no, it's not. Because you see, we still have the same problem. It should only append to one and not the other. The question was, is list a deep copy? Cool. So just so for understanding, let's try and implement our copy method on our dictionary, right? So we do def. Yes. Essentially, that's why deep copying is expensive, because you need to go through and recreate everything like deeply, right? And yes, there's a library called copy. You'll do something like import copy, copy.deep copy, or something like that. But yeah, let's implement copy, right? To implement copy, we can just reconstruct the list, right? So for the sake of explaining how a repro works and eval works and so forth, we can just return the eval of the repro of self, right? And again, all it's doing is it's getting the list, it's reconstructing it and running it through eval and returning that thing. Obviously, that's a bad idea because eval can execute arbitrary code, but we can instead do something like this, right? We'll just get cut to the chase, right? And now we have a method that does copy on our dictionaries. Okay, for now, let's try and see what happens when we reinitialize our dictionary. So let's say like D1 is equal to the dict of a list with 1, and D2 is equal to D1.copy. Well, let's just say it's equal to D1. We'll print D1, D2. We'll print whether D1 is equal to D2, and we'll print whether D1 is D2. I missed that. Dict is not defined. What are you talking about? Because I reset it. All right. So we run this and we get what we expected to get, right, with the lists. Our dictionary object has the same problem with our lists. And so both of them are the same. Both of them the same object because we just copied the name tag. So let's try and just use our copy method, right? Now, they're clearly different. Sorry, they're clearly the same, but we can like add another item. They're clearly different, but yet our equals method returns true or false, sorry, right? Wait, no. No. Hold on a minute. What I'm trying to show is this. They're clearly the same, but our equals method returns false. And that's because by default, if you don't implement equals, it will just use is instead. So how would we implement equals for our dictionary? We would just do def equal self other, and then we want to return whether the two underlying data structures are the same, right? So we can do self.data is equal to self is equal to other.data. But now we might have an issue, right? Because we're storing our lists as a list of key value tuples. And theoretically, we can insert an item, remove it, and then insert it again. And doing so would move that item to the back of the list. So we're not checking for ordering. And we can solve that easily. We can just do sorted self.data is equal to other self.data. And now we have an issue here where data is like, we don't really want to like look inside the contents of the object. So sorted will look for the iterator of our object, and our iterator is defined as this. So it's just going to sort all the keys of the dictionary and see if they're the same, which is not what we want, right? And this is where we would implement items and then actually do the sort on the items instead, like something like this. Cool. Let's see if I'm missing anything. Okay. I think that's all I have time for. I wanted to go into decorators, but I think this is more than enough. I hope that this has helped you understand Python a bit better, and you can kind of gain a better intuition on how exactly it works. But are there any final questions?
If there are no other questions, can I just say thank you, Evan? And can others also
worries.
say thank you? Oh, there is actually one other question.
There is a question, yes. Would EQ normally use repr? No, because EQ, like, you want to compare the data inside the dictionary. And it might be fast to do the comparison with actually checking the objects themselves rather than checking whether the two strings are the same. But again, I guess comparing the representations of the two objects might be correct. Wait, let's see. So if we define a range object, it's like 0. We can also define a range object that starts at 2, finishes at 1, and increments by 1, right? And this would, both of these would be empty. Cool. Cool. Okay. If we do wrapper on these, can you see the issue now? Both of these are equal, but are defined in different ways, right? Because here our range function starts from 2 and finishes at 1. And so we never actually like go do anything. Here it's very clear that it's just zeros. And if you were to compare these two strings, it would be wrong. You could, but it might not always work. Cool. Any other questions? Okay. Cool. The other question was, how would we be able to access the notebook? I will post up this notebook and my other notes later in the talk. Sorry, later tonight. They're not going to be exactly the same because I didn't think I'd be covering try excepts, but it's still a good reference. Yeah, and then the video will also be up very soon. But yeah,
Thanks
awesome.
again. Thanks,
No
Evan,
worries.
and thanks
Thank you everyone
for
for coming. It was wonderful to give this, and I hope you've all understood better. If you want to contact me, my email is not like that. There we go. Cool. That's my email. Feel free to contact me and ask me questions or anything else that might be bothering you. But yeah, awesome. I think that's the end of the talk.
Yeah, thanks everyone for coming.